So I'd like to start with just a quick review of distributive property. Remember that this means three groups of all of this. So again, this would be like saying, I have this bag of M&Ms, but two of them are missing. Just make an M there. Two of them are missing. Now, if I have three sets of that, it means that I have three bags of M&Ms, but there are two missing from each one. So altogether, I have my three bags, but I'm missing, so I'm putting a minus sign there, I'm missing 6. How many M&Ms is that altogether? I don't know, but if you tell me how many are in each bag, I can figure it out. So let's keep the numbers smaller. So let's say that there are 10 M&Ms in a full bag. So if I eat 2, if there are 2 missing from each bag, 10 minus 2 would be 8, and then, so 10 minus 2 would be 8, and then if I have 3 sets of that, that would give me 24. Or I can come over here to the simplified expression, the 3x minus 6, and I can say that those 3 full bags would have been 30, but 6 of them are missing, they've been eaten, and altogether that's 24. So it works both ways. Now, if you look at this next one here, we have a minus sign, which means we actually owe that. We owe 3 bags, but there are 2 missing from each bag. So it sort of means like I have this bag and I'm taking out 2 before I give it away. So if I take 2 out before I give it away, then I get to keep it. I like that. So what this then would mean is that I owe 3 bags. Here we go. I owe 3 bags, but if I get to remove 2 out of each one, then that means I'm actually keeping, oops, forgot to change it, I'm keeping 6. And we can again use the basic rules. Negative times positive is negative. Negative times negative is positive. And so we get a negative 3x plus 6. So let's take a look at this problem. The first thing you always want to do is get rid of the parentheses, because the parentheses are like a wall. You can't really simplify things inside and outside it. So what we're going to do first is do the distributing. So I have 2 groups of 3x, and I don't know what x is yet, but I now have 6 of them, 2 sets of 3. I also had 2 times 4, which is 2 sets of 4, so that's 8. So this parentheses just becomes 6x plus 8. I still have this minus 5, and I still have this 6. So now we're going to combine like terms. Well, on the left side, this is the only x term, but I do have 2 terms here that are constants. So I'm going to simplify those, and I'll say that, well, the positive 8 and the negative minus 5 is going to give me 3. So this is a 6x, and I have 3. I had 8, I owed 5, I still have 3, equals 6. Okay, now it's just like you did before. We're down to 2 steps. What do we do first? We undo the adding by subtracting, and that's going to leave us with 6x equals 3, and that means that this is not that fun of a bag of M&Ms, because it actually only had half of an M&M in it, or let's say half a pound, or maybe even half a ton to make it more fun. And again, we can plug it back in, check it out, and see that it works. Now, let's try something a little bit harder. So take a look at this one. What looks different about it? Well, this one's going to start with a constant, and then you're going to owe all of this. So I want you to try this first on your own. Take a look at it carefully. Remember that you're going to be distributing a negative. So really, you want to think of this as a negative 2 times 3 and a negative, so it's a negative 2 times the 3, and then it's a negative 2 times a negative or opposite x. Use your rules of negatives, distribute it, and remember everything comes after the 10. So pause the video, work it out, and then come back. Okay, so we're going to bring down that 10 because we're not doing anything with that first. The negative 2 times the positive 3 will give us a negative 6, so we owe 6. The negative 2 times the negative x is going to be a positive 2x because a negative times a negative is a positive. So that's like saying I have 3 pounds of M&Ms and I get to take some out. And I'm going to take the same amount out from each bag. So that's the entire left side. So instead of having a 10, a negative 2, a 3, and a negative x, I now only have 3 things. So it's simpler already. Nothing happened on the right side yet. So take a look at this. We have 3 terms on the left, but 2 of them are the same type of term. They're constants. So we're going to combine those first. So let's see what we get here. So that's going to give us a 4 plus 2x equals 16. What do we do next? We undo the addition. Now, you may want to think of this as 2x plus 4 using commutative property, but what we're really looking at here is how are these numbers, this 4 and this 2, connected to the x? How's the 4 connected? By addition. How's the 2 connected? By multiplication, even though the order is reversed. So we are going to undo this first. So we're going to get rid of that 4. Whatever you do to one side, do to the other side. And you're going to see that what do we have now? We have just this 2x left, and on the right side equals 12. And then we're going to divide both sides by 2, and then you end up with x equals 6. Now, you may get a little nervous looking at the problem because it's 3 minus x. But let's take a look at it and really see what happens. Let's make sure it's okay. Maybe I made a careless mistake. I haven't checked my work yet. So we're going to start with this 10 minus 2 parentheses 3 minus 6, because that's what we're replacing. This is the 6, and that's going to equal 16. At this point you have a choice. You can either use order of operations and just simplify the parentheses, or you can distribute it. Personally, when everything's numbers, I like to simplify the parentheses first. So that is what I'm going to do. So I'm going to bring down the 10, and I'm going to say minus 2 parentheses. 3 minus 6 is a negative 3 equals 16. So this negative times negative is going to give me a positive. So it's 10 plus 6 equals 16. And yay, did it work? Yes, it worked. We're good. 16 equals 16. So now that you've seen this, go back to Edmodo and do the second problem set for 1.2, which will be combining like terms and using distributive property, which will also have some combining like terms with it. Again, check your work, check the answer key, ask any questions that you have before you move on to 1.3, because 1.3 is actually going to be building on this but putting the variable on both sides.